Oh man, it's another webinar. Yeah, uh, James and I have been really looking forward to this webinar. We are going to give another 30 seconds or so for people to filter in, but we will get started any minute here. We did want to share a fun story though. James and I apparently both miss conferences a little bit too much. And we independently decided we were going to really try and make the webinar feel like a real conference for us. James, what did you do last night that you shouldn't have?
I mean, I switched to wine. It was a bad mistake. Yeah. So yeah,
Yeah,
a little bit too
yeah.
much.
And I stayed up till 3 a.m. Well, 2 a.m. Not for a conference reason. I found another busted pipe in my house because I'm in Texas, y'all.
In
Uh,
Austin specifically.
yeah, so I had to stay up late fixing a leaky pipe. But yeah, so I stayed up way too late, and James had a little too much to drink, and so this is like a real conference presentation in a nutshell.
Right. Yeah.
Be forewarned. All right.
Yeah,
Well,
let's get started.
yeah.
Yeah. 1 second. Let me turn this back off. I was toying around with the pen option on GoToMeeting. Yeah. So just little housekeeping items. So participants right now, you're muted during the presentation, but please, oh please, ask any questions you want on the message board, from everything for like how we're dressed to basic questions about
What are
I normally wear t-shirts, so don't judge me. Yeah, anyways, we'll answer the Q&A kind of throughout if we see something that's kind of in between for things we're presenting. This is recorded, and again, you will all receive the recording once this is complete. So, anything else to add?
If you talk to anybody that was like, "Oh, I missed this," and your response isn't, "Well, it was a good thing." If your response is, "Oh, it was great, you should have been there," just tell them to go ahead and register afterwards, and they'll get the recording just like you will. So, pro tip.
Yeah. All right. So I'm James Norris, and I obviously work here at ClearEdge. Prior to being at ClearEdge, I was the director of BDC and also centralized planning and scheduling at Beck. Prior to that, I started off as a field engineer doing surveying, and then moved into the project management route. But then I just loved how buildings went together, and got into scheduling, and then really loved them even more. But I got into BIM and laser scanning quite heavily. So yes, I have a lot of experience. I've been in the industry since 2006. I still to this day mentor AEC startups, and I'm also part of the Construction Progress Coalition. For any of those who are interested in that, it is a great program. So you can always reach out to me, and I can get you in touch with the good old Nathan Wood. On the side, I rock climb, and I love to ski, although I'm in Atlanta, so I can rock climb, but I can't ski. That's it.
And I'm Kelly Cohn, also VP of Industry Strategy here at ClearEdge 3D. We tag team the industry side of things, and Chair of Technology Committee at USIBD. Spent about 10 years as well. I think technically my first year was 2007. So James has me beat by a year. But yeah, just really looking forward to doing this today. It's something that's come up in a lot of our Scan to BIM University classes. It's something that this kind of topic of control. So yeah, let's get going, man.
All right. It seems like I instantly in the middle of this, my webcam has had some issues, but that's fine. Okay. So we are going to start off with why control matters. Kelly, do the honors.
So control is something that we talk about a lot at Scan to BIM University. It's something that I think most people, when they get started scanning, you pick up a scanner, start doing cloud-to-cloud registration or targets because it's easy, it's fast, there's little automations that come with it. But as you do bigger jobs and you start seeing errors in registrations, you pretty quickly realize that some kind of control is super duper important. So go ahead and hit next slide for me, James. So, there's a couple reasons why control is really, really useful on scanning projects. The first one really is accumulated error. So anybody that's spent time with a tape measure knows this the hard way, right? If you take a bunch of small measurements and then you add them all together, and then you take a much larger tape measure and take one big long single measurement, you will get a different number. And that's because every time you make a small measurement, there's always some error. There's no such thing as a perfect measurement, right? Same thing's true with laser scanning. When you're doing cloud to cloud, you're doing multiple setups. In this little example, there's 13 setups on this one, little exterior facade of a relatively small building, which means there's some amount of error between all of them. As opposed to control is usually established using a total station, and they have much longer ranges. They take lots of measurements at the same point, so you get really accurate single measurements, and so it really allows you to get rid of that accumulation. So 13 positions versus a single measurement. Go ahead and hit next slide for me. That's the difference between plus or minus 13 millimeters versus plus or minus 1 millimeter. If you think about the potential compounding error, assuming you are getting plus or minus 1 millimeter in your cloud-to-cloud matching, which is probably a little bit optimistic. Now, doesn't mean it's always 13 off. It might be 6 off, it might be 2 off, it might be 8 off. But that accumulated error is something that can really bite you particularly on larger projects and in long corridors, long facades, things like that. So yeah, so it really adds up. So doing these single measurements for control really lets you kind of rein that in and get it down to kind of a minimum number of overall measurements. So let's go ahead and hit the next one here. So the other kind of critical thing for having a control system, and again, doesn't have to be a survey control network that you're tying into, just some kind of control network. Could be assumed on the site, could be kind of project coordinates, whatever. But getting some kind of control set up allows you to consistently bring your point cloud in to multiple applications across multiple companies and have it actually show up in the right place every time. I don't know if anybody's ever messed around with like trying to nudge a point cloud and rotate it into place in Revit. If you're the only person doing that, and that's the only application you're using, okay, I guess that's okay. I mean, you can't do it super accurately, but you can probably do it good enough. But man, the moment you want to pull that into Navisworks and have the point cloud show up in the same place, ugh. Or what if you wanted to, go ahead and hit next slide for me. What if you wanted to pull it into Recap, since now you can bring Navisworks models into Recap? Oh, well, if you didn't have that set up correctly, good luck. Same thing if you want to go into Tekla, if you want to go into any other platform, having that consistent alignment across multiple applications, it's really, really important, to scale the technology. All right, let's go ahead and hit the next one, and then I'll turn the ball over. And then the last one, and this one I'm personally passionate about, is QAQC. So over here on the left, we have the error metrics coming out of Cyclone for control points. Over here on the right, we have the error metrics coming out of Recap for cloud to cloud. Overlap balance in points under 6 millimeters, and then you get some RM, root mean square error average of those points. And again, if you've done any registrations in bathrooms, places with mirrors, lots of glass, you'll know that you'll get a cloud-to-cloud alignment and everything will be green. But when you look at it, it's like rotated 90 degrees, or it's completely shifted off, or it's something else. The cloud-to-cloud gives you statistical metrics based on the algorithms that are used to do the match. But if they picked bad surfaces or bad alignment, the statistical metrics can be great, but the alignment can be feet, hundreds of feet off. So you can't really trust metrics with cloud to cloud. They're just kind of a guide. You really have to QAQC that individually if you have control points and targets for that matter. It gives you a great mechanism to QAQC your registration, and it gives you like human readable errors because it gives you a vector, you know, your X, Y, and Z error in millimeters. I know how to read that. I don't know how to read 2.11 RMS error. And I know a lot about the algorithms since I'm on the software side. So if I can't read it, most people can't read it. So cool beans. And with that, James.
Yeah, really quick, just to ensure, generally, can everybody hear us? Just want to make sure I saw a question come in, so. Okay. Okay. Great, thank you. Yeah, that's a great point, Kelly. I think, you know, talking about, you know, establishing control for a job, and we're going to really speak to why it's important. So imagine this is a scan of the structure of a mid-rise building, for instance, right? If a building, you know, if nothing has been designed yet, for instance, and if you're scanning existing conditions only and nothing has been modeled, you know, you can get away with doing cloud to cloud and not establishing control, although we will actually speak to why that's still dangerous, but you can get away with that. The minute that a building is getting built and then you are doing something like validating, has something been installed correctly, or we're going to scan because we're tying a really unique facade to the exterior of a building, or whatever you're doing. Not tying into control can be just devastating for your job, and also for you as the person performing the scanning. Here's a good example of why. So if this was, I see all too often people will scan and they will align a scan of the floor to the design model, but you know, how many jobs are perfectly built? The answer is like none. So if you align your scan to, say, a column that's 2 inches off, well, now relative to that floor, everything else is going to be 2 inches off. Or you may align and think everything is fine, and really there's all this stuff that's been installed incorrectly. You will never catch it until it's too late. And you know, the point of scanning, especially as a project is getting constructed, is to catch issues. And so if you have something control that we see here, if you were to tie into that survey or that control network used to build a building, all of a sudden the scan is shifted and it will highlight installation errors or something that you should truly be concerned about. And it could also keep you from thinking something is, you know, you may align wrong and then there's a red herring. Something may have been installed correctly, but the way you aligned it made it look like it wasn't. So it's very critical, you know, especially as you're pushing scanning on projects or you're selling it as like a way to mitigate risk, that you tie into control whenever possible. Now, depending on the piece of equipment that you are using, it is very important for you to understand what kind of targets you can utilize. So we have survey targets on the left. There are scanners that can actually utilize those survey targets, as well as total stations. Planar targets, those are fairly popular for cloud to cloud. You know, you'll see every cloud to cloud job I've seen, right, or been on, we use a lot of paper targets that we mount to walls so we can constrain ourselves to those things. And then there's geometric targets, which are also really awesome to utilize as well, especially at distance because of their unique shape. Besides that, you know, if you are setting control for the first time, you can literally just put monuments, you know, or nails in the ground, or use a Sharpie to establish this is the thing that I'm going to set up on. And what we mean by that is, well, we'll actually get that in a second. So before we get into setting control, for those who are, you know, thinking about getting into surveying for scanning jobs, you know, traditional robotic total stations can be fairly expensive, but there are, you know, some good and cheap investment options for you, like the LM150 from Topcon, and there are others. I just suggest looking at that if this is your first bout with looking at starting surveying. It's super low cost. itself levels. It has a great range for most jobs you're going to be on, and Bluetooth technology, so you're not worried about losing tracking of the instrument itself. If it was like, or at distance, if it was just Wi-Fi.
Yeah. Actually, it's funny, James. We got a question coming in from Scott Reed, one of our customers, Prolog, and apparently Scott just picked up an LN to supplement their optical total station. And so yeah, I mean Scott, it's a great instrument for getting control out there. The thing you can't do with it that you can do with your optical total station is bore sight, a black and white crosshair on a target. But you can, of course, as long as you've got the pole with the rod, you can set it up on any floor targets really easily and basically use it the same way. So just kind of depends on how critical that ability to bore sight. But some of the other stuff that you'd shared with us in terms of having that cool stick at an angle, things like that. If you put prisms on those things instead of spheres, absolutely you can use the LN to do very similar stuff. So.
Mm-hmm. Yeah, exactly. And it's really just a simple instrument. It's the kind of thing you don't have to really be an expert at surveying to utilize it. I think that's the scary thing. A lot of people can mess up setting control because the software, the instrument itself, just requires way more expertise than most people are trained on. So something to think about. Okay, so let's say there is a job that you were wanting. We were just, if you remember prior, we were showing the scan had shifted. And we're like, put yourself on control. So how do you do that? Well, if there's nothing out there, or if you want to set your own control that you can use as a source of truth if you come back to this job over and over again, or you're going to give that to a design team to model from, so they can use that in Revit or whatever. You start off by marking a point on the ground, and then you set your instrument on that point. And then you walk with your prism and shoot in another point. And you want to make sure that the distance is pretty good. I mean, imagine if your next point was only 5 feet away, and then the point after that is 100 feet away. There's air, right? Because these poles, you reduce air the farther your shots are from each other, is what I would say, to keep it simple. So you set up on your first point, and if you know where you're going to end, so imagine we're going to build effectively a square around this building, then we may want to save time, shoot in the point where we're going to finish at. And then we're going to just make our way around the building. So we're going to reference the last point we were on, and then we're going to turn 90 degrees or 100 degrees, whatever it needs to be, shoot in that next point, and then rinse and repeat. Super simple, really fast. And then all of a sudden you have a coordinate system that you can reference for your scanning project. Something to note. So when you, just like with scanning, if you traverse with a scanner, and traversing, right, is you're doing a setup, you're moving. You're doing a setup and moving, and in the distance between that, those lines is called the traverse. And what best practices for setting control in a job is you want to close the loop. You want to make a full polygon, right, or complete your square. And this is effectively a polygon, or it is a polygon. So with that, all polygons have 360 degrees inside of them. But as you traverse, you actually just accumulate air, right? There's a little bit of human error. There's error in the instrument you're using, no matter what it is. But not to worry, the software, the field software you're using will automatically distribute that error across this polygon, and then what you have is a very tight control network that you can rely on consistently.
So those of you that've done a lot of scanning, you've seen this when you go down a rectangular corridor with your scanner doing cloud to cloud, and then you come back, and when you get back to that kind of same area you scanned the first time, boom, all of a sudden you've got visible error in the first scan and the last scan that you then have to go through and build a link between them, and then you rerun it, and hopefully that closes everything up tightly. But same thing is true, with total station measurements, the difference is instead of 100 measurements between the first and the last scan, you have 3 or 4 or 5 or 6. So those kind of check-in points are much more. The errors are much smaller overall, but there is still an error to correct for. So.
Yeah, yeah. I've seen a few more questions like so. One from Scott regarding concyclone registers or seeing register C to C and honor control. Yeah, but and we'll actually get into that near the end of the presentation. Just FYI on that one specifically.
We did have somebody talk about prism poles. There's an inaccuracy in the sense that they have to be leveled, and the level bubbles can go out of calibration. And there are, of course, techniques that you should be using to calibrate them regularly. There are other much smaller mechanisms. There are pin poles. You can also have permanently mounted prisms. You can, again, shoot targets. So you're spot on that there's a lot of, John, there's a lot of different ways to kind of measure a point and carry that control around. So yeah, all very true.
Yeah, I would say specific to prism poles or calibration, you can just give us a call after on some of those because there's things called a peg test you have to do with your other things, but they're normally handled by whoever supports your maintains your equipment, if it's you or who you bought it from. Any advice on grid or ground coordinate systems from Shannon? If there is a job that has a coordinate system, ask for it before you get to the job. If you're going to be doing scanning, if they don't have one or they don't have control in a place or survey points in a place that you will need to reference your scan data from, just tell them where to put those things. And I can talk a little bit about that here coming up right now, actually. So now we've closed the loop, we've distributed the error, and we're ready to scan. Okay, so imagine if you're on a project and we're on the top floor and if we're doing installation validation, right? For instance, it could be anything you're doing. You want to ensure that you have line of sight of the prism, so whether it is a sphere or a target, you want to set those up on these points, and they need to be, if you're doing this floor to floor to floor, keep them in the same spot each time you come out to a job, right? Always stay consistent with what you're seeing. Line of sight matters. For instance, what you'll do though is you may start here and set up your scanner. You can see this one and you can see this target. That's fine. And then you might you may scan over here, and you can cloud to cloud these, but then by the time you get over here, right, you can then reference hopefully this existing sphere. You want this target and then also this target over here. The point is you want to be able to see really at least two targets that are referenced from each scan where possible, so that you can tighten up your registration and kind of remove that error. That is the point of setting control. And this is something I see a lot of projects not do, like they'll go out and buy a scanner, and then another thing to note is they don't realize the scanner they bought, the distance that they may set their control back is too far for that scanner to accurately pick up that sphere or that traditional survey target. So you really need to know the constraints and should always ask whoever you're thinking about buying a scanner from what the distance requirements are. Some scanners can pick up a target, 300, 400, 500 feet away, and others are really only good up to 100 feet, 70 feet. It can be really, it's very critical that you know that, or all of a sudden your control may not really be worth a lot. So always ask. That's not always something people know, and something I kind of constantly run into when I'm giving people suggestions. So to be wary of. Let's see here. Let me get back into, good point, John, on state plane.
Yeah.
Okay.
All right. So since we talked about targets earlier, and obviously just talked about targets right there, I did want to throw out just a couple of best practices for targets. Because again, you can use targets to establish a control network just by placing a target at a measured offset from a building from a building corner, or from the intersections of walls or something like that. So there's a lot of great things you can do just in terms of, establishing a kind of on-the-fly coordinate system using some targets that you can, find a corollary, measurement inside of the CAD files or inside of the model. So with that said, there's some pretty common mistakes. Go ahead and hit next slide, James. So, for starters, when we give people targets, like in the first time we take them out scanning, I watch them walk around and hang all the targets roughly at head height. And basically what you end up with is this nice plane of targets in a space. And the way the target recognition algorithms, the matching algorithms work in the software is they're looking for unique 3D geometry. And so the problem is, well, if you have everything on a plane, you've basically limited your unique 3D geometry to 2 dimensions. So, go ahead and hit the next slide. So it's really important when you're hanging up targets and you're using them as a supplement to cloud, make sure that you hang them at different elevations and that you put them on not just vertical surfaces. It's really helpful to put them on, a floor or ceiling, things like that. Anything you can do to kind of increase the 3D complexity of those targets, the auto matching will work much better in those cases. It's super useful if you're like in a core and shell space with a regular column grid. Cloud to cloud's going to fall apart. If your targets are all at the same height, your auto matching targets are going to fall apart. If you can just kind of randomly vary them, you can usually use targets to get everything stitched together appropriately. So wanted to throw that out there. You'll also notice, you definitely need targets in both rooms. You can't just hang them in one. So you got to make sure that as you set up your scanner, you're really thinking about which targets it can see when you're using this kind of mechanism. So,
yeah.
All right. Go ahead and hit the next one for me.
Well, I think this is important too, right? So to ensure you've got good overlap, did you say that when you're going through doorways or openings, to ensure you're always scanning right in the center of the doorway for the opening?
Yeah, I was waiting for the, slide, but yes, no, it came up, James. It hadn't yet. So yeah, that was yeah, exactly. And in fact, you can also scan right on either side of the doorway. It kind of depends on how constrained the doorway is and how constrained the room is, whether you need 1 or 2 scans at each door. But yeah, that's another kind of common mistake when people are relying on cloud to cloud is not being able to do that. If you've got good targets and you've got survey control, you don't need to be as paranoid about that. In general, having targets and survey control reduces the number of scan setups you need to completely register the job. So there's always a trade-off there in time. All right, man.
Yeah, and Shannon had a good question. What if you can't see control from the outside? The windows are installed. What is your advice to put control for subsequent revisits? And now all the surfaces have been covered over as it is being built. Well, in that situation, you may have to reset control, traverse, up the building. And big thing to note, if you're going to do that, you'd want to set control going up each floor if you can, which means you need to go up one set of stairwells and then traverse down the other set of stairwells. And because you effectively want to close a loop. Stairwells can be kind of dangerous for surveying up, so you need to be very careful with that. We have an answer though for you can also set control to the stairwell, then scan up the stairwell and constrain them. So that's one option. Also, if you can get on top of the roof, it may require a little bit more of an answer for you because every job is different. I don't know visually what your line of sight, other constraints are, or what the intent is. So it could be something we can leave for QAQC, I guess, because that actually happens to a lot of people. And sometimes the end result is you do this, you reset control, you scan, and then you tie your existing scans back to this new set of control after the fact. Yeah, other things. So when C2C is not a great option by itself. So repetition is not always your friend when you're running cloud to cloud, right? If you don't have enough unique geometry, or it's if you look on the right-hand side, right, it's just this long hallway that looks literally the same all the way down. The algorithms are trying to find things to connect themselves to, and it's one that's creating overlap, but it's also looking for unique geometry, right, to tighten up the registration. this is dangerous for cloud to cloud, you know, and that can be dangerous if you have a lot of, also if there's a lot of glass or if there are mirrors everywhere, that's like a total killer for scan jobs. So what do we do? So if we have too much reflection, we have just a completely repetitive shake where nothing really seems to be unique, what do we do? Well, we have an example project for that. So this is a conference center with a lot of, you know, there's glass everywhere, and generally it's just not unique. Every room is the same. And how do we protect ourselves from that when we say, hey, we're going to go do this job? Well,
if anybody's been to the Marina Bay Sands in Singapore, that floor plan may look familiar.
one question, would you feel comfortable shooting through a window if single pane? No. It's going to refract. It's going to kind of affect the angle if you're shooting down on control. I strongly suggest not shooting through glass ever, even if you can see the control through the glass, even if it's single pane.
Open a door, get up on a roof, shoot from the roof, carry it in through the stairwell, go in from the ground floor, carry it up through the stairwell. Just shooting through glass is never a good idea.
Yeah, right. Okay, so if you are going to be surveying, you can also do kind of like 2 for the price of 1 situation to become more efficient. Because a lot of times when we're making fee on our jobs, you know, we did a lot of scanning consulting in my past. You know, it's about how much time you can spend on the project and reducing the amount of labor hours while setting control, while scanning all at the same time. A good option is there are hybrid instruments out there that can set control and scan. The GTL 1000 is definitely one of them. I think it's a phenomenal instrument. It runs 360 dome scans. It's super, you know, it's really fast and highly accurate. So for this job, right, we basically found the corridors where we weren't very, you know, one thing, it's a large project. We wanted to kind of create this closed loop. So we create these control scans and use those scans as anchor data. So we did that story prior, right? We set up on a new point, shot on the next point, but then at each point that we were occupying, we scanned with the GTL and all the way around, and then it runs through in like 10 minutes and registers itself to the coordinate system, and then you just bring that into Cyclone and tie that to all the other scans that you are using. One thing to note is make sure that if you're going to use C2C with this, that you have overlap. So if you're using a Faro or an RTC or a GLS, you scan in those same similar areas just so there's enough overlap to do C2C, which means you don't have to tie directly to the control point, which is great. Here's a photo, a screen capture of the scan itself. It's super accurate, easy to model from, which is the thing that matters. That's why we do it. Yeah, and so in an ideal situation, one person is setting control and scanning with a hybrid instrument, if you have that option, and somebody else is just blasting through with their standard terrestrial scanner, an RTC. NS70 or whatever, or GLS, ZNF, you name it. And the other thing it's really good for is we have if the blue is the GTL, the yellow is, you know, call it a Faro or RTC or whatever, and third is mobile scans. So it's also really great for time mobile scan data too. You know, depending on the mobile scanner you're using. So just things to think about when you're trying to attack a job, especially with the size of the job and what the use case is for. The benefit though is when you have a hybrid instrument, one you can scan, you can use it just as itself as a scanner, and then it becomes your anchor data, and you can rely on that always, which is very key. Another thing really quickly, when you have a hybrid scanner, when you're traversing up a stairwell, you can scan in that stairwell instead of setting control. because you set your control at the, imagine you've got a stairwell right at the opening doorway. You can set a point right there, set your sphere or your target, I mean, on that point, but then just scan and traverse up and scan again, and that becomes, scan data. There's a lot of points to tie to. It's registering to itself doing C2C, but then tying to the floor below. So something really cool to think about when you're thinking about new ways, and the new ways we can think about bringing control up a building. Much safer method.
Yeah, and one thing to point out, since stairs were brought up as well as doors, you always need 2 stairs, and you want them on opposite corners of the building, right? Or you want multiple doorways, hopefully on opposite sides of the building, because going back to that closing of the loop, when you want control, you don't want to just go through one doorway, because it creates a little rotation point. And rotation is 9 times out of 10, rotation errors is what causes massive problems on laser scanning registrations, because that rotation compounds over distance. And it can really bite you. So you always want to have those, go in the front door, go in the back door, go in the back stairwell, go up the front stairwell. Make sure that whether it's with control, setting points, whether you're scanning, whatever it is, whenever possible, make sure you get that kind of second point to anchor back to your exterior control network. Super important.
Yep. It's hard to think about, because there was a really good point, like always stress having long backsides. 100%. Meaning you don't backside something, or you don't backside something that's 10 feet away, then shoot a point that's 100 feet away. But when you are scanning up a stairwell, it's the chain. It's hard traditionally for anybody who's done surveying to think of it in this way, but your error is still so small when you're doing C2C up both sides of the stairwell, tying to control from the floor below that have which is really great. Yeah, so the TopCon, right? The GTL 1000, we have tuned it to work now with Verity, Edgewise, and Rhythm. The scans are quick, 1.5 to 3.5 minutes, depending on resolution settings you want. Yeah, and the fact that it's dome scanner is great. Let's see what we got here. So for Verity and the GTL, right? So it's a plugin for Navisworks. It's great for analyzing, has my building been built right? And it's a great way to hold your job or people accountable on the project to make sure that you don't have profit erosion on your project. And then it publishes the BIM track, Procore, and BIM 360 field, which is great. Those are kind of the most pervasive project management tools used. And then another very kind of ubiquitous task, right, is floor flatness. So you can always scan the floor, run it through Rhythm, and get an ASTM 1155. That's important for, like, if you're building ice rinks or you're doing data centers or anything where floor flatness is very critical. Let's see what else. Oh yeah, go ahead.
One of the things I was going to throw out there is, I think this is one of those, the reason we want to bring it up is a lot of these kind of more recent workflows that are leveraging laser scanning for a lot of different things. They really are best suited to having a control network and tying into a control network so that you're getting absolute measurements and results. It's, getting relative results on, installation validation or floor flatness is a lot less helpful than getting absolute results on it, but getting absolute results requires some kind of control network and tying into it. So,
and then for Edgewise, which is really what got ClearEdge, kicked off, and is a product that is used across, MEP, FP on whether it's commercial construction or plant. We've now finally tuned it to work with the GTL, so the results are actually really good. And we rather show how it really works versus saying, oh, it's perfect. It's pretty darn good. So there are 330 pipes picked up on this plant project for the ones for this. I don't know if this was a cut, and only 33 bad pipes, which means there's not a lot of modeling that you have to perform. and it'll literally only miss 2 pipes over 3-inch diameter on the job. And that's it. I think we're deep right now into questions. We got, 18 more minutes to really just go into people's questions and ensuring we're answering them correctly.
Shannon tossed out that yeah, she's always been in the habit of, or I guess I shouldn't assume that she or he have it's a name like mine. You never know if it's a guy or a gal. Will loop up a stairwell, scan a level, and go back down a different stairwell, so that's vertically closing the loop. So that's a great practice. So absolutely, it's a great way to do it with scanning. Same thing works on anything else with total station, same practice, very much, scanning is basically an application of a survey instrument to something that's not, necessarily traditional surveying. So a lot of the same rules apply.
Yeah, a few questions. Thomas, we'll kind of work our way up and down as well. Where you have shiny epoxy coated floors in factories, any advice on ensuring good floor flatness during registration? Well, scans don't like shiny objects, right?
Or black objects.
Or black objects. So in that situation, I would say it depends on what the requirements are. So it may be best that's why like a GTL or having a survey instrument is good, because then you can just walk a standard grid and shoot the points with your prism pole or whatever you're using and walk a standard grid. The other option is to put targets, like those paper targets, on the ground at a certain distance in between each other over a long grid, and then scanning and then picking those up and trying to find the deviation. That would be my response. If somebody else has a better idea, I'd love to hear it.
Yeah, when you're doing a burn, when you're burning a slab off doing something like that, and you've just got that glossy dark coating, it's really, really hard to use any of the scanning technologies to collect reliable data on that surface. But yeah, having a hybrid instrument is great, because if it's a surface that works with the scanner, you've got the whole kitchen sink to throw at it. If it's something that you can't, you can always put that total station part to use. Another question on the GTL was, does it work as a standalone scanner? And the answer is yes. We do. It does. I think the medium res scan in 3 minutes and the high res scan in 6. It's not. It doesn't scan as fast as an RTC. It also doesn't cost as much as an RTC. And it's got all the total station hardware underneath it. So it's really, when Topcon launched this thing, I got really excited about it because, back when I was at Beck, we had one scanner, and it was a scanner capable of survey, but it was really slow. You had to set up targets. It took a lot of time, so you didn't do it very much. And you couldn't tie into most of the control that was already on the job sites, right? You couldn't shoot a prism, you couldn't shoot a retro, you couldn't shoot, there's just a lot of stuff that you can't shoot. It has to be done with a target. And so, just the flexibility of being able to have a total station and have it do scans, and then kind of the workflows that a hybrid instrument like that enables. And there are other hybrid instruments out there. Right now, the GTL is the only one that scans as fast as it does. Full dome scan in 6 minutes is wicked fast for a hybrid instrument. But
that's resolution too. So you don't know.
Yeah.
I think I saw wet on here. What about for wet projects? If you're scanning wet concrete, there really aren't many scanners out there made for that. The GLS is one of them. Like, it's literally made for scanning wet concrete. So I just give us a call. We can kind of shoot you in the right type of equipment. I think.
Yeah, because John, the GLS was actually made for horizontal work, so it's designed to shoot hot asphalt, which is black and shiny. So that's the GLS, not the GTL. That is a scanner that has a pretty good chance at working on wet concrete. We've had good results with that. Black and wet gets a little bit trickier, but yeah, reach out on that.
Have you done a lot of tenant improvement projects? This is from Ted. that had no control. Yeah, like almost all of them. It's funny, you're saying we seem to have a lot of those and need to tie into targets and then get to slice of the point cloud draft. Yeah, so for TI work, like it's relative to itself, right? If it's just that floor you care about or a few floors that are tied to each other, I just, in that same vein, we set our own control network that we can reference to consistently on the job. And until it gets covered up, and normally by that time you don't care. Once you're getting into like floor finishes and like millwork, it's fine. But when you're everything prior to that, I normally set control always, and then reference everything from that. Because the worst thing you want to do is you have, what do we always find, right? We have like a design, a TI CAD drawing or model, so it's a 2D CAD or Revit model, but it may not be right relative to what's actually been scanned. So I like to set control, then scan, and then give that data to the architect, and then put them on the same shared coordinate system so we can fit what we mean, right? So it's just basically both the design model and your coordinate system you established are actually on the same coordinate system, and then you can just see where there are deviations. Then you write an RFI to the architect, say, hey, we need to, that column that you drew is not actually where it really is. Please move that so that we can properly, buy out the job or whatever, or have this documented for your as-built for the owner at the end of the job. Let's see, what else do we have? Cool, what else we got?
Well, one of the other things I wanted to add to that is like, a great workflow for kind of establishing a local just project control network in a kind of statistically valid way is to do offsets of things that are supposed to be regular, like for instance, a column grid. So you can kind of do a 2-foot offset of 10 or 15 or 20 columns, put a control point at that 2-foot offset, and then when you do all of your measurements, you kind of have those control points, the column dimensions, how they're supposed to be, and then you can basically statistically average to get the best fit on all of those columns. And that's a really good statistical way of aligning a point cloud data set to a to a physical building and all the digital design files associated with it, because you can see the error in each column. And you're making an informed decision. If you just do 2 or 3 columns, you're just praying that those 2 or 3 columns happen to be installed correctly. So if you're gonna have to rely on a kind of internal alignment system like that, rather than just like nudging it into place and guessing, or just picking a couple things, pick some big long walls, or pick columns, or pick something that's usually pretty reliable, pick a bunch of them, give yourself kind of a physical offset in the real world, and then you can correlate that back to the drawings and to the digital files, again, in a really nice statistically kind of validated way, if that makes sense. All right, well, it looks like we got most of the questions.
Yeah, we have a few more coming in. I use points on window frames and door jambs for control. They rarely change once installed, and they are not covered. Yeah, you can use that. You can use, if you can find unique geometry that's not going to change, and you can reference that, that's great. If it's not going to move, it's not going to get dented, or something you can see in your registration software, totally.
One pro tip there, when dealing with anything on the exterior wall with a lot of thermal expansion and contraction, if you're dealing with really tight tolerances on the job, try and make sure that you use internal elements, door frames that don't have a lot of thermal shift, because you would be surprised how much expansion you can get on a metal or aluminum window frame that's touching the outside air. If you're fine with 1/4 inch accuracies, then who cares? But if you're really trying to do something down to 1/8 inch accuracy, 1/16 inch accuracy, you can get some pretty surprising shifts on those things. Internal things that don't have temperature gradient, those things are pretty reliable.
Yeah, and then another question, I've actually seen this come up a few times on some on jobs as well. In your opinion, from John, what are the best types of wall-mounted targets if a project setting will not allow for setting up spheres based on traffic and people? Yeah, so it's like, hey, I've got this, in a situation where, let's get back to this situation, right? So, current slide, come on.
Well, while you're looking for your example, my answer to that is I love the convenience and flexibility of paper planar targets.
Mm,
Whether they're printed on cardstock if you need them to be a little bit rigid, or whether they're just printed on plain old printer paper. You can hang them up anywhere. A little bit of tape, they'll stick to anything. If you need something permanent, I've seen some great printing of them on metal plates that you can plug in, but every software works with it. Not every software works with spheres. Every software, not every software recognizes a little paddle target. So,
yep.
it's reliable, works for every scanner. It's super cheap. And as long as you're aware that when you hit them at a high angle of incidence, you don't get great accuracy, just don't use targets with a high angle of incidence. But
Right.
you can just hang so many more targets. You can afford to hang so many more targets. So to me,
Well,
that's a go-to unless you're in a big open space like a warehouse. And if that's the case, spheres are freaking fantastic because you can shoot them from any angle and you don't have to go back and touch them every damn time.
that's exactly right. If you, yeah, and if if imagine there's a street right here and you just cannot, you really don't have something you can tie to. Things I've done is if there's adjacent buildings or a parking deck, they'll many times allow you, I try, and we have to get permission from the building owners if you can. Um, but if you can, these things are screwed in, right? So you can actually permanently mount targets like this that you can reference. And I did that for when I was just basic surveying too. So whether it's scanning or surveying, something you can constantly reference as a job goes vertical, or just even if it's a factory, and just finding something that is fixed that you can find line of sight to, um, ask for permission to do that. Or if it's on your own job, just build, pour some concrete, and because you don't want to stick it in dirt because people run over that kind of thing. Pour it in concrete, flag it off, and screw in a sphere, or screw in one of these targets that will always be consistently in the same place.
Yeah, and that's somebody asked the two. I think we have time for these last two questions. First was a question on scanning a building before and after you remodel, and as you may guess, given that things are changing, cloud to cloud is really risky, because if you scan, when sheetrock's up and then you scan again after you put hang tile, well, guess what? That's a substantial difference in thickness. The cloud to cloud registration software is not going to know what to do with that. You're hosed. So, this is yet again one of those cases where control is super, super important. When you have a changing environment, control is what allows you to correlate reality, across multiple different scans over time. And then James, somebody actually asked the team up question, so we can answer the team up question. So, yeah, my Marvel Universe team up, I guess, is I find that like there is no single scanner. So the question, sorry, is what is your preferred go-to scanner?
Oh,
My answer is there's no single scanner that's perfect. The RTC is an amazingly fast scanner, but it doesn't have a dual axis compensator, so its levelness is crap. And as is every other scanner that doesn't have a dual axis compensator. On the other hand, you go with a high-end survey scanner with a dual axis compensator, they're super expensive, and they're not as fast as the RTC. So like, to me, like, my dream team right now is actually the GTL 1000 and the RTC, because the
yeah.
GTL 1000 is a survey instrument with a DAC and a scanner. So that workflow that James showed earlier, where you kind of use the GTL, go to intersections, go inside, outside the building, but at every setup, you do a full dome scan. You now have scan data that is on control, super globally accurate.
Mhm.
That scan data is then the home scan world you register all of your RTC scan data to, and you can blow and go with your RTC, not worry about getting it super level, collect a ton of setups and data, and then just tie them all back in. And it's like you get this amazing, end product that you just, it's so much more work to get there if you're doing it with a total station, setting up targets and spheres on control points, blah, blah, blah. It's just so much more work. So it's like, that is my dream team right there right now. So if I were to, leave ClearEdge and open up my own scanning shop, those are the two instruments I'd buy. Because man, you can do, with those two, you can do anything. So really, really, really fun kind of workflow. And I think, James, we are pretty much at time. Yeah, we've got some other questions that are kind of filtering in. If anybody, asks any other questions, we will follow up with them via email and just kind of let you know. But yeah, James, thank you so much for pulling this all together. And Paula, thank you. Paula's our director of marketing who actually makes all of this stuff work in the background. So thank you both for getting this all pulled together.
Yeah,
Hopefully everybody else had as much fun as me.
I see these questions. We will, I see your names. I believe, Paula, do these questions stay static so we can respond to each person?
Yeah, James, we get them all afterwards.
Awesome, yeah. So for those that we didn't get to, I will respond. I saw one on Open Traver, so I was gonna say it depends, but I do have it's definitely an option. Yeah, so.
All right.
All right, everybody.
Well, thank you all so much for coming. Pleasure to have you. Check out ScandiBIM University if you haven't. That's our kind of sister channel of webinars. We're doing a bunch of educational stuff over there. I know we've got some other webinars coming up with ClearEdge as well in terms of some survey equipment and stuff that we're going to be selling. But yeah, it's just really great for everybody to spend an hour of their day with us. So thank you all, and look out for that recording.
Yeah.
Cheers.
Later, peoples. Have a great one. Stay safe. Cheers.